So hello everyone. Today we are going to solve our next question on LeetCode, that is insert, delete, and get random. So here this randomized sets class is given, and inside this class there is a constructor and there are several methods. And what we have to do is we have to implement this randomized set class, and it is the constructor that is given. It is basically used to initialize the randomized set object, and after that we have given a method that is insert. So it is taking this value as parameter and its return type is boolean. And we have to what we have to do is we have to insert an element well into the set if it is not present, and we have to return true if it is not present, as we will return false. After that we have given this second method that is remove. It is also taking this value as parameter, and it is also returning boolean. So in this method we have to remove an element well from the set if it is present, and we have to return true if it is present, otherwise we will return false. And this third method is GetRandom, which is returning integer and it is not taking any parameter. Here in this method we have to return a random element from the current set of element, that whatever element we have inserted into our data structure, from all these elements we have to return a random element, and it's always guaranteed that at least one element exists in the array at the time of performing this operation get random. And it is saying that each element must have the same probability of being returned. Now you have to implement this function in a way that each of the method you can implement in O of one time complexity. So if you will implement this insert function, it will also take O of one time complexity. Similarly, these both also. Now let's try to implement these. So here what we can do is, so the first approach is to take a hash set. Why we are taking hash set? Because the insertion and removal operation in hash set will take place in O of one time complexity. So let's take this hash set here. So this is our hash set. Now let's say we have multiple elements 5, 6, 7, 8, and 9. Now we want to insert these elements into this hash set. So to insert these elements, simply we can take this element and insert into it. And this insertion operation will take O of one time complexity for every element. So similarly, we can insert 6, 7, 8, and 9 into it. So here we have implemented this insert function using hash set, as for every element, it is taking O of one time complexity to insert into hash set. Now we have to implement this remove function. Now, if we want to remove any of the element from this hash set, then removal operation will also take O of one time complexity. So let's say if we want to remove this 7 from here, then to remove this 7, it is going to take O of one time complexity. Simply we will remove this. So it will be removed from this hash set. And similarly, all of these elements can be removed in O of one time complexity. So using this hash set, we can also implement this. We can also implement this removal operation. Now the third operation is get random. Now in this get random operation, basically we have to return a random element from the current set. So what we will do is simply, instead of taking this element, we will simply consider the index of this element. So let's say if there are 5 elements, the index will be from 0 to 4. Now what we will do, we will simply create a random function using these element, and this random function will return these element these all elements with the same probability. So let's say it is returning 2. Now in this hash set we will iterate using iterator, and we will try to find the element which is associated with this second index. So we will go here in this hash set and we will try to find the element that is associated with this 2. So let's say this is the element, so simply we will take this and return this. After that we will return this. But now as we are iterating into this hash set using iterator, so it is going to take O of n time complexity, which is not good, as we have to implement all of these functions into O of one time complexity. So here the requirement is to implement this is in O of one time complexity, but here it is taking O of n time complexity because here we are using iterator to iterate through this set. So we cannot perform this get random operation using hash set. So we have to use any other data structure to perform this. So here what we will do, the second approach is, what we will do here is we will take two data structure to implement this new data structure. First, we will take a array list here. So this is our array list. And after that, we will take a hash map. So this, why we are taking this array list? So basically we are, instead of array, so we are taking this array list because we do not know that how much elements are going to be inserted into this list. So if we will take array here, so array is not dynamic, it is static. That's why, as we do not know the number of element that will be inserted in future, so that's why we are taking a dynamic array here, such that it can handle any number of insertion operations. That's why we are taking this. Now let's say initially we have these 5 elements to be inserted. So I'm going to make the size of it as 5. And this is the hash map we are using here. What it will store? It will store key and value. And it will store element as a key. So it is going to store the element as a key. And it will store the index of these elements in this array list as a value. So value will be index. So what we will do is, let's say we have to perform this insertion operation. So for this, we will simply take this element and insert it here. So these are the indexes. So we will simply take it and insert it here at this place. Now to insert this, it will take O of 1 time complexity to take this element and insert it here at this place. And what we will do then, we will insert it also into this hash map. How we will insert this? We will store this element as a key. So we will store this element as a key and this index as a value. Index as a value. Similarly, we will take each and every element, and there might be some internet connectivity. So let me see on the screen. So what we were doing here, what we will do, simply we will try to insert each and every element into this array list, and we will also store it as key and value into this hash map. So we will take this element. So we will simply take this element 6 and store it its index as 1. Similarly, this 7 as 2, 8 as 3, and this 9 as 4. Now this is, here we have implemented this insertion function as it is taking O of 1 time complexity. So we have implemented it in O of time complexity. Now the second function is removal. Now, how to remove these elements in O of 1 time complexity? So what we will do is, let's say we want to remove this 7 from here. Now to remove this 7, what we will do is, we will simply swap this 7 with the last element. So after the swapping, what will happen is, these elements will be swapped and this 9 will come here and this 7 will come here. After that, what we will do, we will simply delete this last element from here. So we will simply delete this last element from here. And now as the index of this 9 is changed, so we also have to change this index. So we will come here at this in the hash map and we will change the index of this 9. And now as this 7 is deleted from here, so we will also delete it from hash map. So this is how we can implement this removal function in O of 1 time complexity, because in this swapping it is taking O of 1 time complexity. After that, what we are doing, we are removing the last element, so it is also taking O of 1 time complexity. After that, we are coming here in this and to change this, change the index of this new element, and it is also taking O of 1 time complexity. So it can be, so this removal function can be implemented in O of 1 time complexity. Now our third function is GetRandom. How we will implement this? So let's say these are the indexes. These are the indexes for all the elements in the array list. So now what we will do is, let's say now we will implement a function, a random function, and it will return these indexes to us. So let's say it is returning 2. So what we will do is, we will simply go into the array list and we will check for the element that is associated with this index 2. So this is the element 9, which is associated with this index 2. So we will simply return this 9 from here. So we will simply return this 9 from here. After that, let's say if you want to remove this 8, then to remove this 8, what we will do is, let's say it is giving us 3. It is giving us 3. Now, to remove the element, what we will do, we will come here in this array list and we will check for the element that is associated with third index. So at this third index, there is 8. So we will simply remove this 8 from here and return this 8. So this is how this third operation, that is get random, can also be implemented in OAuth1. So this is how all the functions can be implemented in OAuth1 time complexity. Now let's try to code this. So to code this, what we will do is here, initially we have to take a hash map. So we will take a hash map of both integer, because we are storing elements as well as the index of the element. So both are integers. So we are taking hash map of integer HM, and also we are taking a list of integer. So here we are also taking a list of integer. After that, we have to initialize these both. So we will initialize these in this constructor. So come into the constructor and do hm equal to hash map. So I'm going to initialize these both. Here list equal to new array list. After that, what we will do is we have to implement these all functions. So first, come to our first function, that is the insert function. So how we will do this? First, we will check in the hash map whether hash map contains this element or not. So if hm dot contains key, which this val, in that case, what we have to do is we will simply return false, as there is no need to insert it further, as it is already in the hash map. If it is not in the hash map, then we have to add this in to the list. We will add this in the list, and simply we will put this into the hash map as it is not in the hash map. So well, and list dot size -1. So after that, we will return true. Okay, so this is our first function. Now we want to implement this remove function. So to implement this remove function, what we will do is, first we will check whether hm dot contains key, this val, and if it is equal to false, if hash map doesn't have this key val, then in that case, what we have to do is we will simply return false. We will simply return false. And after that, what we will do is we will take a index. So we will take an index here, which is equal to hm dot get val. So we will simply take this index from hash map. So it's get val. Okay. And after that, what we have to do is we will simply swap. We will simply swap both the element into the array list. So we will simply swap both the elements, and we have to swap in the element into this list, and we have to swap the element having index this and the last element, so which is equal to the size of the list -1. So this will represent the last element. And after swapping, what we will do is we will take a variable, let's say swapped with, and after that we will try to get that index with which we will swap this value. So we will try to get this index, and after that we will simply put this value, this with the new index, into the hash map. So we will simply put this into the hash map with the new index, swapped with the index, new index. After that, what we will do, we will simply remove the last element from the list. So we will simply remove the last element from the list. And we will also remove this entry from hash map. And after that, we will return true. So this is our second function. This is how it is implemented. Now we want to implement this random function. So for this, we will take use of this random class. So we will create an object of this random class. After that, what we will do is we will simply use the function random dot next int of this random library, and inside this we will pass the size of the list, because we will tell here that we have these number of elements and you have to find the random value from these number of elements. After that, what we will do, we will simply return this list dot get n. So we will try to as it is going to return us the index, and on the basis of this index we will go to the list and we will try to extract the element which is associated with this index, and we will simply return this. So now let's try to run this. And it is accepted. Let's try to submit this. So it is working fine. So that's all for today. Thank you.